Hello everyone, welcome back to my YouTube channel. First of all, subscribe my channel and press the bell icon for more updated videos. Today our topic is designing of HVAC system for healthcare facilities or hospital. Here you can see the drawings of an hospital. It is one of my project that I have completed in previous month. So in this, first of all, we have to check which type of rooms are these. So in this you can see room 1, room 6 and room 5. The room 1, room 6 is intensive care units, that is ICUs, and the other rooms are considered to be protective environment, and these two rooms are isolation room and anti room. So we have to design an HVAC system for these facilities for this hospital. So we first of all we will check the criteria that is provided by the NC ASHRAE ASHE standard 170. You can check this standardized table that in ASHRAE 170 2017. I have extracted these data from this document. This is the document. Here you can see critical and intensive care units. This is the defined data by ASHRAE. So I have extracted these all data from HVAC ASHE standard 170. So here we will start from critical intensive care unit. For this calculation we will use HAP. In this, minimum outdoor ACH is 2, minimum total ACH is 6, and all room air should not be exhausted, that is not required. Relative humidity is 30 to 60%, design temperature is 21-24. So we are going to design system for this room 1. You can see here for this room 1, that is 7 feet 8 inches by 10 feet and its height is 9 feet. So here we will start how to calculate its cooling load, how to provide the air requirements. So we will calculate all of them. Here we will start from the HAP. I'm going to select ASHRAE standard 2010 and just press OK. For weather data, I'm using the Middle East, and it's Pakistan, Karachi. So just press OK. And for space data, that is the room number 1, and the floor area, how much the floor area. You can calculate the floor area by just multiplying this 7 into 8 by 10. So 7.8 multiplied by 10, that is the 78 square feet of your floor area. So you will just put 78. 9 is the ceiling height and the building weight is medium. And how much outdoor air requirement, like this is defined by the HAP and ASHRAE. So just uncheck this and click user define. For this, use percent of supply air, or you can just add CFM. As you know, the minimum outdoor ACH is 2, so you can calculate the outdoor requirement 1 for this. It's simple method. You have just multiply the length and width by height. So you will get the volume, multiply this volume by ACH and divide this by 60. So this is the 23.4 CFM required for your room, that is the fresh air or outdoor air requirement. So you have just put 23 CFM. This is your actual outdoor air requirement or fresh air requirement for your system. And now for the second step, you have to just add overhead lighting. If you have overhead lighting, recessed type or recessed vented. We have recessed unvented. And how much wattage you are going to use in this room. So Here I have a table of ASHRAE IES 90.1 for lighting power allowance using the building area method. I am using the 2010. So for healthcare clinic or for hospital, here you can see it is 1.21 watt per square feet. So I will add this 1.21 watt per square feet, and I don't have task lighting, so just put it 0. And for scheduling, you have to use hourly profile. So in case of my hospital, the lights will be on 24 hours. So I am going to select the profile 1, that is 24 hours on, and this I just add this one. And for electrical equipment, I don't have any electrical equipment in my room. You can add this if you have any. And I have only 2 persons in this room, which is the user defined, that is 250 BTU per hour, and latent will be 205 BTU per hour. And the scheduling, you can use profile 1. Oh sorry, you just add this person profile. Like if you know how much time you have the patient in your room, like this is only for 4 hours from 9 to 8 or 6, depend upon on your timing. So in our case of hospital, the whole area is occupied 24 hours. So I'm going to use profile 1. Let's just press OK. And if you have miscellaneous load, you can add these. If you don't, so just put it 0 and leave it. Now for wall and windows. So in my case, I have north, east, west, south and west. I have 4 walls in my room, which area is here you can see in this triangle, this is the 7 feet and this is the 10 feet. So I need this wall of this area, wall of this area, wall of this area and wall of this area. So the wall of this area is 10 by 9, that is 90 square feet, 90, and same for south, 90, and this one and this one is 7.8 by 9, that is 70.2 square feet. So I have to add 70.2 square feet, and same for this one, 70.2 square feet. And I have to define the wall. My wall assembly is 8-inch common brick. My wall is my hospital wall, that is the intensive care unit wall, is made of 8-inch common brick. There is no airspace, and there is only 1 by 2 inch plywood, low weight concrete, and finally the stucco. You can add different materials depend upon on your wall material, which type of material are using to build your wall. So in my case, I am using this assembly, and you can also use default assembly, that is the lightweight wall. The HAP just define these by defaults, and you can use different types of material here. So in my case, I am using the 8-inch common brick, low weight 4-inch low weight concrete, 1 stucco, and just I don't have insulation. Just press OK. If you have any window in this is your north side, sorry, this is your north, this is your south, this is your east, this is your west, depending upon your building location and coordinates. So if there is any window in north, south or east, you can just put it here. Like there is a door in south, So I will provide this data here, that is south. There is one door, and there is no window, so I'll just press 1. If you have any window in north, so just window 1. If you have 2 windows, just put 2. So in my case there is no window in my room and there is only one door, so just provide the door details here. Gross area of door, my door is 7 by 4 feet, that is 7 by 4, which is 28 square feet. So just put 28 square feet and leave it other thing as on. And for roof light, I don't have any roof that is exposed, so just leave it as 0, not used. Infiltration, for infiltration you can use ACH of 0.02, that is almost 0.23 CFM. And if there is floor above this condition space, in my case there is another roof above another portion above the hospital which is already conditioned, so just press floor above condition. If there is no floor above your hospital and it is exposed to sunlight, so you just press floor above unconditioned space, provide the floor area and the other thing. So I will just press this one. If you have any partition, you can add ceiling partition, wall partition. I don't have any, so just press okay. Select the wall assembly that I have checked in previous. You must correct the validation. Okay, create a new wall, 8 inch, 4 inch, 1 by 2 inch gypsum plaster, depend upon your wall, and just press OK. Okay, just select the wall for each of this, that is the lightweight wall, for this lightweight wall, for this lightweight wall, for this lightweight wall. If these 4 walls are made up of different materials, you can just define different materials for this wall, for this and this. So it's depend upon you. Just press OK. So this is one of the first step is completed. Now we are going toward the system design. Just click on it. I am using the split air handling units, that is the air handling unit with the condensing units, and I am using the constant air volume single zone. So just leave these like this. And for system components, for ventilation air, I am using the HS standard 62.1 2010 and leave these thing as on. And just for dehumidification, like I have defined in this, that is the 30 to 60% humidity you will need for this critical intensive care unit. So just press add 60, or you can add an average of 30 to 60. And for central cooling, I'll just leave it at 58 Fahrenheit, the supply temperature of the air. And for supply fan, I am using backward inclined air backward fan, which is not here in this. So just click the default by forward curve with damper. And I'm using a drawn through fan, which is the backward, which is not included in this, but it doesn't affect your cooling load. And for duct system, just leave these things. And for zone, just add room number 1 in zone 1, and just add some thermostat scheduling. For thermostat scheduling, I will use profile 1 because my hospital will be operated 24 hours. For these hours, always occupied, so I will use profile 1. Just give it name for thermostat and press OK. If your hospital is on different routine, like it's operating from 5 to 9, 9 to 5, you can add these hours and scheduling for your thermostat. And for cooling set points like 75 centigrade, you can I'm going to design it for 21 and 24. You can add 21 to 24 centigrade in your this data. So I will convert this 21 centigrade to Fahrenheit, which is the almost 21, that is 69.8. so 69.82, and if it's unoccupied, just leave it this and press OK. Before leaving this, the final main step is supply terminal. Just add the ACH method and put the ACH of 6 for this, and using same criteria for these other facilities. So just add 6 for ACH, 6 for intensive care unit room 1. We are going to calculate for this one, and if there is any zone heating, you can add the data. If you don't, so just leave it. And for reheat coil system, I am going to use electrical resistance reheat coil for dehumidification, and just put data if you have any and leave it. And just computer generated, click the computer generated, and for zone sizing, leave these things as on and just press OK. Okay, your heating thermostat set point is okay, it's must be 80, 75, 70. Okay, just put these values. 65 is your heating thermostat set point, and 69.8 your cooling set points. So just put these values and press OK. Now just press this icon, view design report. Wait for this. This will generate system sizing summary, zone sizing summary. If you need zone load summary, just click it here. If you don't need, just leave it as hourly air system load, hourly zone load, which type of thing you need, just press these. So I am just need these things. Just press preview. It will generate a report. Here you can see the total load required for the this room 1, that is 0.5 ton of 0.4 ton, which is almost around about 0.5 ton, and we have to add some factor of safety. So you can use the 1 ton and 280 CFM for this area. This is the design report of this. According to this, you can design a duct system. You can choose AHU use the same criteria from room 2, room 3, calculate all of them and add the total CFM. So you can design your own project. Here you can see the room 1, that is the 280 CFM, the supply requirement, and the total space, total other details are defined in this document. You can check this. If you any question, you can ask me in comment, and you can also watch my video on HAP that I've previously uploaded on my channel. So this is the one of the calculation method. I'm using this. You just need these criterias. You have to define about your what type of hospital you have, what type of room you have. If you are going to deal with isolation room, just read the criteria. If you need total fresh air, just define in space here 100% supply air. 100%, you will use 100% supply air, and these 100% supply air should be exhausted 15% more than supply air. for empty room and isolation room. So the criteria of calculation is same, just you need these values from ASHRAE tables, and you can calculate on your own of your project. So after this we will discuss about the AHU selection. If you calculated all CFM, like I have one of my generated data, I will share with you. Here I have one data, that is, let me check. Here you can see the my project details. I have calculated the whole system tonnage for this section. For this section, excluding isolation empty room, I have calculated the cooling load, the supply, CFM according to ASHRAE standards. So I have got this one. I've got the results of 25 tonnage is the total requirement, 10,429 is the total CFM required for AHU. So I am going to select in AHU according to this maximum block CFM at July, which is 11,571 CFM. So I will select this type of CFM for an AHU. I will install the AHU which provide this much CFM. Here you can see the simple model of the AHU required for hospital, in which you will install the back filter here, MER 7 and MER 14 filter for pre and final filtration, and after this you will install the HEPA filter in supply terminal. You will use this type of non-aspirating perforated terminal for hospital facilities, which is the non-aspirating laminar flow device, and should be designed to limit the air velocity at patient bed to reduce the possibility of patient discomfort. The perforated diffuser with planium box and filter box. The filter should be HEPA H13 or H14, depend upon your type of particles, contaminants in your room. And this fall in group E, which velocity is limited to 20 to 35 fpm, which is very necessary. It's very important in your during your duct design, and this is one of the important parameter for your patient. And for AHU, and another thing, this diffuser should be made of SS304 stainless steel or aluminum, which is the recommended by the ASHRAE or FGI and different facilities. For AHU, like I have defined, MER 7, MER 14 with HEPA filters in supply terminals. For PE, for negative pressure rooms, for intensive care unit, the criteria is same, the calculation method is same, everything is same, just you have to need these data from ASHRAE. And for duct detail, you must design duct according to SMACNA and ASHRAE standard. So supply air for the room generally is located in ceiling at the foot of the patient bed. The in intensive care units and other facilities, healthcare facilities, the supply diffuser should be located at the top of the foot of the patient bed, and exhaust air taken from exhaust grill or register located directly above the patient bed, on the ceiling or low on the wall near the head of the bed, and it should be 150 to 200 mm above the floor, and when the head wall exhaust grills are mounted lower than 7 feet above the floor. Supply duct should be installed with HEPA filter. Exhaust duct will also be with HEPA filter to control the contaminant in the outside environment. And I have defined, the minimum of 2 low grills should be installed for return, which is the 8 inches above the floor shall be provided, is the recommended by the ASHRAE 170. So these are the details of the hospital design. If you need anything, you have any question, you can ask me in comment. Thank you for watching my video.